Ever wondered if we are alone in this vast, infinite cosmos? This question has long been a matter of intrigue and speculation. The idea of extraterrestrial civilizations, their existence or lack thereof, has been a subject of countless debates. Today, we delve into the top 5 theories that ponder this galactic conundrum, each as fascinating and mysterious as the universe itself. From ancient astronauts to the perplexing Fermi Paradox, we've got a lot to cover. Let's embark on this cosmic journey, traversing through the labyrinth of time and theories. Our first stop is in the distant past, with the ancient astronaut theory. This theory proposes that extraterrestrial beings visited Earth thousands of years ago, influencing the course of human civilization. Proponents of this theory point to a wealth of unexplained archaeological evidence. From the precise construction of the Egyptian pyramids to the intricate carvings of the Nazca lines in Peru. They argue that such feats would have been impossible without advanced technology. Technology that was perhaps brought by visitors from the stars. Ancient texts and art also fuel this theory. Tales of sky people or gods descending from the heavens are found in cultures across the globe. Could these stories be early interpretations of alien encounters? The theory is controversial, of course, with skeptics arguing that human ingenuity alone could account for these ancient wonders. Could our ancestors have had otherworldly visitors, or is there a more mundane explanation? The ancient astronaut theory keeps us asking, searching, and wondering about our place in the cosmos. Next, we delve into the realm of numbers with the Drake equation. Now, this equation isn't your run-of-the-mill algebra problem. Conceived by astronomer Frank Drake in the early 60s, it's a hypothetical attempt to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way galaxy. Let's break it down. The equation is not a hard and fast rule, but rather a collection of variables that, when multiplied together, give us a rough estimate. These variables consider factors such as the rate of star formation, fraction of stars with planetary systems, number of planets that could potentially support life, the fraction of planets where life actually develops, and the fraction of life that develops into intelligent beings. Now here's where things get interesting. The last 2 variables consider the fraction of civilizations that develop technology that releases detectable signs of their existence into space, and the length of time for which such civilizations release these signals. The beauty of the Drake equation is in its flexibility. Alter any of these variables and the estimated number of civilizations can swing from billions to just one: us. But remember, the Drake equation doesn't provide definitive answers. It's a tool that guides our understanding of the factors involved in the search for extraterrestrial intelligence. So the universe could be teeming with life, or we could be a cosmic anomaly. But if the universe should be full of life, then where is everybody? Welcome to the Fermi Paradox. This is a question that has puzzled scientists and philosophers alike for decades. The Fermi Paradox, named after the physicist Enrico Fermi, presents a curious contradiction. You see, given the sheer size of our universe, with its hundreds of billions of galaxies each containing billions of stars, the probability of the existence of intelligent extraterrestrial life seems incredibly high. Yet despite our best efforts, we have yet to detect any signs of it. This paradox raises a series of intriguing questions. Are our methods of searching for extraterrestrial life flawed? Is our definition of life too narrow? Or perhaps intelligent life in the universe is extraordinarily rare, or even unique to Earth? Some theories suggest that civilizations may inevitably destroy themselves once they reach a certain level of technological advancement. Others propose that advanced civilizations may be avoiding contact with us, or that they have already come and gone, leaving us none the wiser. These possibilities challenge our understanding of our place in the cosmos. They fuel our curiosity and drive us to continue our search for extraterrestrial intelligence. After all, the implications of finding or not finding other intelligent life forms in the universe are profound. Are we alone, or are we just not listening hard enough? This question, at the heart of the Fermi Paradox, leaves us with much to ponder. As we look up at the stars, we can't help but wonder what or who is out there. What if the silence is intentional? Enter the zoo hypothesis. In the grand cosmos, we find ourselves questioning, are we alone, or do we have cosmic company? The zoo hypothesis presents a thought-provoking answer. It suggests that extraterrestrial civilizations might be consciously avoiding contact with us. But why would they do so? Imagine the universe as an interstellar zoo, and Earth, our home, is one of the exhibits. Advanced alien civilizations, the zookeepers, might be watching us, studying us, all while maintaining a respectful distance. This non-interference could be due to several reasons, from preserving our natural evolution to protecting us from the potentially harmful knowledge of our cosmic insignificance. It's a humbling and somewhat unsettling thought, isn't it? That we could be under the watchful eyes of entities far more advanced than us. Yet they choose not to interact, to let us grow and evolve in our own time, at our own pace. But there's also a comforting aspect to this theory. It suggests that these cosmic zookeepers harbor no ill intent towards us. They're not here to invade or conquer. Instead, they observe us, perhaps even protect us from the vast unknown dangers of the universe. So the next time you gaze up at the stars, wonder this: are we truly alone? Or are we just part of an interstellar wildlife preserve, observed from afar? Could we be an interstellar wildlife preserve observed from afar? As our journey concludes, we are left with more questions than answers. We've pondered the ancient astronaut theory, tracing the possibility of extraterrestrial influence on early civilizations. We've weighed the Drake equation, a mathematical formula suggesting the existence of numerous alien civilizations. We've grappled with the Fermi Paradox, questioning why, given the vastness of the universe, we've yet to encounter any signs of extraterrestrial life. We've considered the zoo hypothesis, proposing that we're like animals in a cosmic zoo, observed but not interfered with by advanced beings. These theories, each intriguing in its own right, provide us with a variety of possibilities. Yet none can definitively answer the question of extraterrestrial life. They are, in essence, educated guesses, hypotheses waiting to be tested. As we gaze into the cosmos, we're led back to that haunting question: are we alone? So, are we alone in the universe? The search continues, and perhaps one day, we will find the answer.